Hey guys, what's up? My name is Gabe and this is Games with Gabe. This is the next tutorial in the Coding Geometry Dash in Java series. If you remember from the last tutorial, we got to camera rendering and everything and transformations and all that stuff. And we can now move objects across the screen. I did run across one bug, which is if we change the scale of that player, you will notice, that it will not be rotating about the center. So it rotates weird. There's a really easy fix for that too. If you just go to the player class right here, and then just change this from, we're rotating about the anchor width over 2. Instead of doing that, we can just say width times GameObject.transform.scale.x over 2, and then height times GameObject.transform.scale.y over 2. And that should fix that bug. So if we go back, it works perfectly now. Basically what that's doing is it's just transforming it. So it's saying where our anchor point is actually be according to the scale that we're at instead of just according to the width. And so that makes sure that it's anchored at the correct position. Pretty simple, not a big bug. In this tutorial, what we're going to be doing is we are going to be making our player fall, hit the ground, and then start going to the right. So it's technically going to be going to the right the whole time, but we'll be doing that and then having the camera follow the player as well. It should be pretty simple, shouldn't be too hard. So we'll go to our level editor scene. First of all, there we go. And we're going to need a new game object. So we will call this game object the ground, which is very simple, but so the ground. And then this is going to need a component, which we will call, as you would have guessed it, ground. So the ground component. This is going to extend component, and then we're going to say Alt Enter to import that from Jade. Let's go here, Alt Enter. That's all good. And then we will say public void draw graphics 2D G2, and then we're going to override this. So we'll say at override. This is just our method to draw it. And then what we'll do is we will simply say G2.draw rectangle. And then we're going to say whatever this guy's x.transform.x.position.x GameObject.transform.position.y, and then the width and the height, which is actually going to be the constants.screen width and constants.screen height. Okay, and then we just need these to be integers, so cast that to an integer, cast that to an integer, and we're good. And reason we're doing screen width and screen height is because what we're actually going to do is we're going to have the ground basically just be a box that's drawn from the left to the right of the screen, and then we're just going to have it follow the camera. So it's basically just going to be constantly sitting there, and it's going to make it look like the player's moving along the ground, but actually the ground is just going to be moving with the camera. Pretty simple, and it's nice because it makes our lives a lot easier because it's kind of hard to create infinite ground. So this is sort of the hack. And we'll actually do -10 for the x and then +20 for the width, just to make sure that we cross those boundaries and we don't have weird lines on the edge and everything. And then before we do that, we'll say g2.set color.black, so that we have black lines. Okay, and then we're going to need one more function, and that is the update function. So I say public void update double dt for delta time. And let's take in a constructor to public void, public ground, and then we will take in a, I'm debating whether we want to take in as the minimum x, so where the ground actually is, like where's the ground, or the y, or if we want to make that a constant. I think that should be constant actually, because it's constant, it doesn't change. So we will say public static final int ground y, and we'll just set this to like -400. We'll see how that looks and stuff, and then tweak it if we have to. I think it probably should actually be like 400. It's probably gonna work better. 800 last time. Okay, that'll probably be good. And then we'll go back to our level editor scene. So we have this game object ground, and then inside of our init function, we will say ground equals a new game object, and then it needs a name, ground, transform, new transform, and then we'll say new vector2 constants dot, well actually 0, and then constants dot ground y. And that's starting to run off the edge of the screen a little bit, so I'll just do this, put this onto a new line, and then we'll say ground dot add component new ground, and then we'll hit alt enter to import that, and then we'll say render dot submit grounds that we are drawing the ground. Let's just see what happens when we run this. So we're moving the player or the camera right now too. Let's stop doing that. I'm gonna take away this scale and then take this away, and then we'll run this one more time. Okay, so we just have the player just rotating about right here, and we do not see the ground at all. So the player's X and Y is, let's see, player 500 and 350. So let's try 350 for our ground and see if that works. Let's go back to our constants, and then we'll change this from that to 350. See what happens. There we go. Okay, so we see the ground right here. Let's move it down a little bit. So I think like probably 500 is gonna be better. Do 500. Nice, that's better. And then we're gonna go just a little bit lower. Could do like 700 so that we can actually see him falling and make sure that the falling gravity works properly. So 700, it's right there at the bottom. You can barely see it, but that's good because then we'll be moving the player down. A couple more constants we're going to need. The camera's offset to the player in the X direction. So public static final int camera offset X, and we're going to do like let's do 200. That might be, we'll see. We'll tweak values and stuff. Tweaking values is, you can spend a lot of time on that, but we don't necessarily need to. So let's go back to the level editor scene. We have all this, and then inside of our update function, what we'll say is if the player's transforms positions X minus the camera's position X is greater than, and then we'll say constants dot offset X, camera offset X. Then we'll say camera dot position dot X equals, and then we'll say player dot transform position X minus constants dot camera offset X. And so basically what this is doing is just saying if the player's moving to the right, then move the camera with it. Let's hit F10. We should see the camera in the right place. There we go. Okay, so this is 200. I might increase that a little bit because I think 200 is just a little bit too small. So we'll do 300. Let's see what 300 looks like. There we go, that looks good. So 300, and it's going to maintain this offset. If we move the player to the right, we'll see that nothing will actually happen. The ground will look like it's moving, but nothing will happen with the player. So let's go back to the level editor scene, and then we'll say camera dot position dot X plus equals DT times 30F. So 30 pixels per second to the right, or to the left. And then you see the ground is moving and the player is moving too. That's not good. We should be moving the player, not the camera. So player dot transform dot position dot X plus equals DT. Okay. Then if we do this, we see the ground's moving to the left. The player is maintaining his position in relation to the camera. So all of that is working good. Then we're going to need an offset for the Y because we're about to start moving the player in the Y direction as well. So let's go to our constants, and then we will make one more value called public static final int, and this will be the camera's offset in the Y direction, and this will be 400 maybe, and this will be from the top of the camera to the player's top, so that distance. Then we can use this camera's offset Y in our level editor scene just like we did with the offset of the X, and we'll just say if the player's transforms position dot Y minus the camera's position dot Y is greater than constants dot camera offset Y. And then we will say camera dot position dot Y equals, and then player dot transform dot position dot Y minus constants dot camera offset Y. So literally the exact same thing, just in the Y direction instead of the X direction. Then if we move the player down, we should see his state remain the same. So we'll say player dot transform dot position dot Y plus equals DT times 30F once again. and we should see him move down, and the camera starts to move down. So this is actually the line right here. Let's make that a little bit higher. I think he should be a little bit more centered. Go here, make this like 325. Try this one more time. And that looks pretty good. I think this is pretty good in relation. We might tweak things a little bit more too. And then one more thing we notice is we actually don't want the camera and the player to continue going past the ground. So what we can say is we'll go into our level editor scene, and then we will say, instead of continuing the player moving down and the camera moving down, if the camera's position.y is greater than camera.position.y minus ground.transform.position.y is greater than constants.camera offset y. So if it's greater than that offset in relation to the ground, we're going to say offset ground because we're probably going to need a different value. So if it's greater than the camera's offset in relation to the ground, then we'll say camera.position.y equals ground.transform.position.y minus constants.camera offset ground y. So let's code that up real quick too. We'll go into here and then we'll say public static final int camera offset ground y, and then we will set this to like 400 because we're going to need that to be a little bit bigger. So I was actually overcomplicating things a little bit. Just change this offset to 150, and then in the level editor scene, we can literally just check. We can say if camera.position.y is greater than this constant, then the camera's position equals this constant, which basically just means that if the camera's top left y up here is greater than 150, just stop it there. It's a lot simpler. We didn't need to do the whole offset with the ground and everything. That was just, I mean, you could, but this is just a lot easier. So basically the camera stops now once it reaches this position, which is good. That's exactly what we want. So we have the camera's movement constrained to follow the player in the X and the Y direction, and then stop once it hits the bottom of the ground. So now we can actually, instead of doing this, we can go into our, and let's change a little thing real quick too. So instead of doing player.update, let's go for game object G in our game objects. We'll say G.update dt, and then take that out. Just like we have this renderer drawing it, we'll just update every single game object. And then what we'll do up here is we will say GameObjects.add player, and then we'll say GameObject.add ground. That way we get it updated for both of those, and then we should see the same thing happen. And we do, except we were doing all the player rotation and everything inside of here, so nothing's going to happen to that. So let's go into the player class right now, though, and we're going to want to add something to this player that enables gravity on it. So we're going to need something new, a new component. We will call this rigid body. This is basically just the way the player reacts to different physical constraints. And we're not going to do 100% accuracy to physics, but we will try and do a little bit of accuracy. So this rigid body will have a public, do float vx, so velocity in the, we'll do vector 2. So vector 2 velocity. We have the velocity, and then we'll say public final float gravity equals, and we'll do like 200 for now. And this should actually, we shouldn't put this inside of this class. We should put this inside our constants class. So constants, put in one more constant here. This is going to be gravity, which is 200 for now. We will tweak that in a little bit too. So then we will go back to this rigid body, and then this will have a public void update double delta time. This class is going to extend our component class, so component, and then right here we'll say at override, and then this is going to say it doesn't know where this is, so we'll say alt enter. This is all good now. And then basically what we're going to do is we're going to say whatever game object is attached to this, we'll say GameObject.transform.position.y plus equals, and then we'll say velocity. So we add velocity, then we add acceleration. That's how physics works. So the position.y plus equals velocity.y times dt. GameObject.transform.position.x plus equals velocity.x times dt. Then we'll say GameObject.transform.velocity, not GameObject, so we'll just say then velocity.y plus equals, and then we'll say constant.gravity times dt. And did we make that public? We might not have. So constants, public final float gravity equals 200. Yeah, that looks good. Static, we need to make it static. There we go, public static, there we go. Go back to that rigid body. So we increase the velocity according to that, and then we're not going to have any acceleration because there isn't really acceleration in Geometry Dash. I mean, there technically is, sort of, whenever you hit the bouncing things, but we're not going to get to that point. So we increase the position by the velocity, increase the velocity by the position. Then we say if velocity.y, if the absolute value of the velocity.y is greater than constants.terminal velocity. This is just going to be like their maximum speed. They can't go past this because we don't want them to just keep increasing forever. That would not be good. Then we'll say velocity.y equals math.sine num of velocity.y. So this just gives us like negative or positive times constants.terminal velocity. So it'll keep it negative if it's a negative number, positive if it's a positive number, because that is important. And then we'll go back to constants, add in terminal velocity, public static final float terminal velocity equals, and we'll do like 600 for now. We will tweak these when we need to. Let's go back to rigid body. This all looks good. Great. Let's go back to our level editor scene. We have this init function. Let's add one more component to the player. Player.add component. New rigid body, and then we're going to say new vector 2 because we're going to want to supply it with a velocity, and then the velocity in the x direction is going to be, we'll do 30. I think 30 is good, and then 0 for the y direction because that's going to be affected by gravity. So then we go import this, hit Alt Enter, and then it says it doesn't take that, so we'll go back to rigid body real quick, and then we'll say public rigid body vector 2 vel for velocity, and we'll say this dot velocity equals vel. Nice, we're good. Okay, let's go back to level editor scene, see if this all works. So we should see the player go to the right. We see him going to the right, and we see him falling down and speeding up. That's great, cool. Now let's go to our ground because we want the ground to hit the player and then stop the player. So if we go here, and basically what we want is we want to have a reference to the player. So for now we'll just say game object player. We will actually fix this. That's using the actual player in a second. But what we want to do is we want to say if the player's transform.position.x.y plus the player dot, and then we're going to need some reference to the height. So I'm going to say get component boxbounds.class.height because the box bounds will contain the height, and we'll change that in just a second if that does. Is greater than GameObject.transform.position.y. So greater than this y, then we say player.transform.position.y would equal this y minus the component. So get component boxbounds.class.height. And I'm going to move this to a new line. There we go. So it's just basically the same thing we were doing with all the camera stuff and everything, just moving it so that it stays constrained to this position no matter what. It says player was never initialized. Let's actually make player. So we will say game object player equals, and then we want a way to get to that player. We'll say level editor scene dot player, and then we'll go into our dot get scene dot player. So we'll make the scene. Yeah, we'll make the level editor scene instance singleton as well, and then we'll be able to get the player directly off of that. So we'll go to here, and then we will say public level editor scene get scene. This is also static, and then we will go up here, create a static level editor scene current scene We may change this in the future too, because I don't like the way this is going up. This is really not good practice, but we just need a quick and dirty way to get this done real quick. So we will say if level editor scene dot current scene equals null, then level editor scene dot current scene equals a new level editor scene, and then we need a name, I believe, so scene, and then we'll say return level editor scene dot current scene. Okay, and then let's go to our window class real quick, because we're gonna have to change the way this is getting it. We will say it equals not a new level editor scene, but we'll say it equals level editor scene dot get scene. Okay, and then go back here. This is all good. Let's go back up to this ground, and then we say get scene dot player. We need to make player public in here, so we'll say public player, and then we go back to our ground. This should all be good. Cool, except for this. Let's go to box bounds now real quick. Okay, we need box bounds. We'll take in, instead of taking a name, we'll take in a float, a width, and then a float, a height. And we will get rid of this, and then we'll say public float, width, and height, because these are things that every box bounds will need to have. Say this dot width equals width, this dot height equals height. And then that should be good. We'll go to our ground class, and then our ground class is all good. Now there's no issues with that. And then we'll go to our level editor scene one more time, and then we will add one more component to the player, which is player dot add component, and then we'll say new box bounds. This is all stuff we're gonna need in the future too. I don't like the way we're setting it up right now. We're just sort of doing it very quick, but we will need it eventually. And then we'll say player width constant dot player height. Okay, let's see what happens now. Fingers crossed it'll work. There we go. Player hits the ground, and then it just stops on the ground. So we have gravity, we have the player, it's all working right. Tweak those values, tweak the gravity, tweak the velocity and the X. I will do that off camera to make sure we get some good values, and I'll let you know whatever I use in the next tutorial. Okay, now that we have it, he'll keep going too, by the way, because we don't have a boundary for the X's. We're not actually checking, so he'll just continue going forever. But in the next tutorial, what I'm going to start going over is cleaning some of this up, because I really don't like the way we did a lot of this. We will get some proper ways to get to the player and everything, and get some proper ways to set up our class hierarchies and stuff like that. So I hope you guys liked this tutorial. If you did, please hit like and subscribe, and I will see you in the next one. Thanks. See you.